Today we are going to look at volumes. Okay. Well, there are many ways to compute volumes. But for us, we are particularly interested in computing volumes by triple integral. Using spherical coordinates. And this topic may be new to many of you. So let's take a bounded solid in R3. So that E and the problem is the following. What's the volume of the solid E? And as before, we are going to denote the volume by V, the total volume. Okay. And there has to be a formula for it. The formula for it, and one of the students has asked me before. Well, the volume of a solid is going to be the triple integral over E of the function 1 with respect to V. Okay? It's just like finding the surface or the area of a surface in R2. And this can sometimes be denoted by omitting the number 1. So it's the triple integral over E with respect to V. Okay. This is a triple integral. A symbol for a triple integral. It is in rectangular coordinates. or cylindrical coordinates or spherical coordinates. They are all denoted like this. And then if you have decided which coordinates to use, then you formulate this integral in terms of that set of coordinates. So there's not much theory about it. There's not much proof about it. Okay. The whole thing is that we have to know BV in whatever coordinates you choose to use. And that's a little bit theoretical, but we have done that already. So most of these problems are problems by example. So here is an example. So let's try to find the volume of a particular solid. So we want to find the volume of a solid E. Bounded by the following two surfaces. So the first surface has an equation like this. Is x squared plus y squared plus z squared equal to z. It's not equal to 1. If it's equal to 1, you all know what it is. Now, the second surface is given by this. Is given by the square root of x squared plus y squared. Okay. And I want you to find the volume by using spherical coordinates. So we want to use spherical coordinates to find the volume of the solid. Okay, that's the problem. So let me put down the spherical coordinates first. You still remember what they are. But it's good to record this again and again. So you have the X, Y, Z space. Or in short, R3. You take a point here, you drop a perpendicular down to the XY plane. You look at the XY coordinates. Okay. And you are going to look at the polar coordinates in the XY plane. This is R. And this is the ray, and this is theta. Okay. And then I am going to look at the points X, Y, Z here. Okay. And I join this X, Y, Z to the origin. I call this angle the azimuthal angle. Which people know a lot if you are in geology or geography or astronomy. So this is the angle phi. And this is the radius rho. Right? That's all the data you need. Actually, you don't even need all. And then the relationship between X, Y, Z and rho phi theta are the following. Put it here. So X is rho psi phi cosine theta. And then Y is rho psi phi sine theta. And finally, the coordinate set is given by rho cosine phi. And if you remember, theta is between 0 and 2 pi. Phi is between 0 and pi. And rho is positive or 0. I'm not going to write this down. Okay. Now we are very well equipped to solve the problem. So solution. Now, for problems like this, it's always a good idea to sketch the diagram, even though it looks messy, okay? But at least you should attempt to see three-dimensional figures on a two-dimensional plane, okay? But I'm not going to put too much data on the diagram so as to confuse you, okay? Now, first of all, we have to know what the two surfaces are and how they bound a solid. Right? Okay. Let's begin with 1. What do you think about this surface or this equation? What's the surface corresponding to it? We have a set here.
Sphere.
Well, a sphere. There are many spheres. So
Center is 0, 0, 1/2.
let's check. Okay. Okay. This is the same as just complete square. Okay. So it's going to be x squared plus y squared plus z squared minus z. Okay. And then here I am going to complete square. I want this to be a complete square. So what should I do? So I have z squared minus z. And
We need 1/4.
put 1/4. That's very good.
Both sides.
Yeah, it's 1/4. You are correct. I will tell you why. But if you add 1/4 here, I have to add 1/4 here. Right? These two equations are the same. But the nice thing about these three terms is that it forms a complete square. Okay? These kind of techniques are very elemental. But if you cannot think of it, then you cannot solve the problem. So this is what? This is going to be x squared plus y squared. Now, when you complete the square here, it is going to be z minus 1/2 squared. Correct? You expand it, you get this one. And this is equal to 1/4. Now, then it's clear that this is the equation of a sphere, not a ball, a sphere. Okay. All right. What should I erase? Let me erase the top. All right. To mute something. Okay. Now, if you look at this, this is going to be the equation of a sphere centered at 0, 0, and 1/2. And the radius is 1/2. So I am going to end up with something going like this. Know where the noise is coming from. It's okay. Well, in other words, I am going to elevate the sphere from the center to height equal to 1/2. So I have something going like this. I hope it's not too confusing. So I have a sphere going like this. Centered at this point 1/2. And the radius is 1/2. So I have a sphere going like this. Okay. I have a sphere going like this. That's part one. I hope it's not too confusing because I'm not going to write down any letters on it. Next, I have to look at equation 2. So I am going to look at 2, which tells us that Z is the square root of x squared plus y squared. Right? And what is it?
Inverted right circular cone whose horizontal cross section is a circle and the vertex is at origin 0, 0, 0.
Let's use spherical coordinates. Somehow you have to use spherical coordinates in order to understand. Rectangular coordinates are convenient, but they are not always useful for particular surfaces or solids.
I see.
Z is this. Is rho cosine phi. This is why I put down these equations. And then this is what? This is this redundant R. Okay? This is a redundant R. And on Monday, I have told you that this is a right angle. This is where confusion comes from. Okay? When you put a 3-dimensional figure on a 2-dimensional plane, you need to have some perspective, just like in photography. Okay? And this is the angle phi. This is the angle phi. Then what is R? R is, if you look at this one, this is the hypotenuse. R is the opposite side to the angle phi here. So what is it? It's rho sine phi. Right? That's equation 2. And we have to know what we get for this equation. Well, rho is a positive number. We can cancel it. Right? Therefore, cosine phi is sine phi. And then what is the angle from 0 to pi for which this is true?
45 degree.
Hmm?
45 degree.
45 degrees, right?
Yeah.
So this implies that the angle phi is pi by 4.
But Professor, I'm confused that how can I get phi cosine equals to phi sine? No, I mean, how can I get phi cosine equals to phi sine? I mean, rho cosine phi equals to rho sine phi. Right.
It's rho cosine phi, right? And then I explain sometime in interpreting this one. This is equal to R, right? X squared plus y squared square root is equal to R. Again, you have to be able to see that this is a square. Okay. When you look at things from far away, a three-dimensional figure would look something bright. Okay. So you have to know that this is a square, this is R, this is X, this is Y. So X squared plus Y squared square root is equal to R. That's R, right? This is R. But I said before, R is redundant. So I want to express this in spherical coordinate. So I look at this right angle triangle. It doesn't look like a right angle triangle in a two-dimensional plane. But you need to think of this triangle as coming out of the board. And then you have a right angle here. This is the angle phi by alternate angles, okay? This is the hypotenuse. This is the opposite side. So R is rho psi phi. Is it clear? Okay, all right. And from this, rho cosine phi is rho sine phi, and then I cancel the rho, getting cosine phi equal to sine of phi. And the only angle between 0 and pi, satisfying this is pi by 4. We don't use degrees, we use radians. Okay. All right. So it's 45 degrees. So what does it mean? So this means that we have the following thing. Now, you have to keep in mind that Z has to be positive. Z is positive, right? Because it's the square root. So you are going to end up with a cone here. You see, it's already confusing. You have a cone here. Okay. And in fact, if you look at this ray here, this ray is making 45 degrees as an azimuthal angle or azimuth angle, if you want an easier pronunciation. Okay. So let me enlarge this a little bit. Without so many lines. So I am going to have 1/2 here. We draw a thin line here and a thin line here. Okay. Thin line here and a thin line here. Now I have a sphere. Center at 1/2 with radius 1/2, but I don't need the lower part. Okay, because I want the region to be bounded by the sphere and the cone. Okay. This part is not good. Okay, so I have a cone. So you have a cone here, and then you have the upper hemisphere on top. Something like an ice cream cone, right? So now you know what the region is. The region is this ice cream cone. Okay. Now we have to find the volume of this. In other words, you have to set up the integral. And the setting up of the integral is usually the hardest part of any problem like this. Well, of course, the figure is important too. Okay, so how do we do this? So first of all, we try to look at the projection of this ice cream cone on the XY plane. Well, project everything on the XY plane. Then I am going to get a disk. To draw it. So I am going to get this. Right? That's the projection of this solid on the XY plane. Now I take a point here. Okay. And then I am going to see the range of Z from the cone to the sphere based at this point. So it's something like this. Let's say it's something like this. Okay. So corresponding to this point, and then the range of Z is from the cone to the upper hemisphere. Okay. Now we have to set up the integrals. So V is equal to a triple integral of 1 with respect to dv, and we all know what dv is. It's rho squared psi phi d rho d phi d theta. Now, what's the range of the angle theta? 0 to 2 pi. Now, what's the range of the azimuth angle or azimuthal angle? Well, it should actually start from 0, and then you rotate, and then when you rotate, somebody has already told me that the angle is pi by 4. So it's from 0 to pi by 4. Actually, I enjoy doing problems. It's better than algebra. Okay. And then we have to find rho. Is it rho? Oh, I should not take Z to be like this. Because this is not cylindrical coordinates. I have to take this away. Sorry. So what should be the range of rho? Well, rho is actually starting from here and going up to the upper hemisphere. So let's say it's something like this. But actually, this problem can also be solved using the cylindrical coordinates by exactly what I did before, except that you don't use theory. So this is the rho. Rho is from 0 to this point, right? So what is the equation of the sphere again? Do you still remember? Up to what? Well, the sphere, if you remember, is rho equal to cosine phi at the beginning. So a sphere in spherical coordinates is given by this equation, right? Let me double check. Yeah. So rho goes from 0 to the sphere. So it's going to be, what is it? It's going to be a cosine phi. So we have to integrate this step by step. We have to peel off the skin one by one. And as I said before, for simple integrals, it's always good for you to practice doing this by hand. Okay. So first of all, we are going to integrate with respect to rho. So psi phi comes out. Okay. And then psi phi comes out of the rho integration. And then I have the integration of rho square with rho. Sometimes you don't need to write down everything. Do it in your head, if possible. So we are going to have what? We are going to integrate this with respect to rho. So I am going to get rho to the power 3 over 3. Evaluated at 0 and cosine phi. So rho is gone, and we have d phi d theta. This is what I call peeling off the layers. Okay. Now, evaluating rho cube at cosine phi, I am going to have the integral from 0 to 2 pi. And then the integral from 0 to pi by 4. And then I have cosine cube phi, and then sine phi, d phi, d theta. I regard this as simple integration.
Professor, I think you forgot the 1/3.
Yeah, thank you. Let me take this out. Okay. These are constant. Now, how to integrate this? Again, you can do this by inspection. Okay, if you cannot, then you can make a substitution by putting u equal to cosine phi. But I won't bother to do this now because this is basically first year calculus. So it's 1/3. I don't like people saying that the volume is given by this. Okay. It's not informative enough. Okay. So I want to calculate to the ultimate. So I am going to have integral from 0 to 2 pi. Now, if you find an antiderivative of this, then you should have cosine to the 4. Actually, if you can practice doing this by heart, you will gain a lot. Over 4. And then you have to differentiate cosine to get sine. But when you differentiate cosine, you get minus sine. So I have a minus sine here. And then the whole thing is evaluated at 0 and pi by 4. And then finally, I am going to integrate with respect to theta. Okay, then I put pi by 4 into phi. What is cosine of pi by 4? 1 over root 2 or root 2 over 2. Okay, and then you put phi equal to 0, and then you subtract. Okay, when you put phi equal to 0, you get 1. So I am going to get 1 over 12 times the integral from 0 to 2 pi. And then I have 1 minus no. I put phi equal to pi over 4. So it's root 2 over 2 to the 4. I have taken 4 out already. Right? So I get this. And then I have d theta. What is this? This is 1 minus, well, root 2 to the 4 is 2 times 2, which is 4. And then 2 to the 4 is 64, which cancel to give me 1 over 16, is it? Yeah. What did I say? 4 over 64, 1 over 16. So I am going to end up with this constant being pulled out. So I have 15 over 16, 1 over 12 times 2 pi. So what am I going to get? So it's going to be 5 over 32 pi.
Professor,
Yeah.
We should have 1 minus 1 over 4.
Let me see what yeah, I think there's something wrong.
1 over 4. So 4 over 16 is 1 over 4 just.
No. 2 root 2 to the 2, yeah, so it's 4. Yeah, thank you. Right? So it's 1 over 1/4. So I am going to have 1 over 12 times 3 over 4 times 2. Thank you. So it's pi over 8. Which is a much, much nicer answer than a bulk of an integral. Okay? So this is a very good example illustrating all the ingredients of triple integration. So, questions? Next time I will, well, after the test, of course. After the test, I will look at change of variables. Change of coordinates, I would say. And again, many teachers skip this.
Professor,
Yeah,
which sections will be covered on test 2?
oh wow. How many times have I answered this? Oh, I don't even have the book with me. Give me 1 minute. I will write this down anyway, but okay. It's chapter 14, section 14.5, 14.6, chapter 15, chapter 15, 15.2, 15.3, 15.6, 15.7.
Thank you.
Okay. By the way, I have recorded all the lectures. How many students have really looked at the recorded lectures? I'm not too sure anyway.
It is very good because sometimes we need to, even though we watch it live, we sometimes need to go back to review the lesson.
Yeah,
And so we can stop it, process, and then play it again. So it actually serves its purpose.
but I said this, I said about the test during the recording. I didn't turn it off.
Oh, I know, they're in the test, what you just said.
Yeah,
I mean, they're in the lecture.
Yeah, in the lecture, I mentioned all this. And another thing I want to mention, there are 200 students in this class. And every time I saw that there are at most 20 students. I check the enrollment every time. Maybe you read it at some other time. I don't mind it. But I think it's important to read it. The best thing is to watch everything live. I am also teaching an upper level course, and that's an in-person course. And then there are about 1/3 of the students attending. And then I also recorded the lectures for that one. And then I try to see how many students would listen on Zoom. Only 3. And that's a more difficult course. Yeah. But again, maybe they don't have the time and then they read it at some other time. But let me tell you one thing. In the next term, there won't be anything like this. Everything will be face-to-face. Yeah. In other words, if you don't upload your vaccination, whether or not you have vaccinated or not, you are not allowed to enroll. Have you been informed about this? I think you have been informed about this by the university. Okay, so try to be prepared for that. It's just a piece of advice anyway. Yeah.
Thank you.
And in other words, you have to upload all your vaccination proof to the university. If you don't, they don't care whether you have 2 shots. They still don't allow you to enroll. Okay. They are getting tougher. Okay. For this one, for this term, they are more or less trying to do this on an experimental basis. So they are not too strict about this, but next term is the real test.
And for test 2, will we have, how many minutes will we have? How many hours will we have?
Well, how many hours? You are hoping for too much. You
Like an
have,
hour, like a full length of the lecture? The lecture is an hour, so.
you have 15 minutes, okay? You have 15 minutes, but I will give you 20 minutes to upload, just like the first test. Okay? Well, I heard in some classes, the professor gave the students 11 hours to write the test. I think this only invites cheating.
I don't think so. I beg to differ, Professor, because like in one of my courses, we have like 36 hours and it's so hard. You don't have time to go ask somebody to help you. You have to just try to figure it out on your own. It takes in so much writing.
Well, I don't want to make it too hard.
Right.
I want you to do things that I have taught, but I make it shorter. So you also don't have time to consult with people. So it's different philosophy.
It's so hard. You don't have time to do anything else but just think about what you've done already.
Yeah.
So that's kind of why I practice so much, because
So if you practice a lot, and
exactly,
you should be able to finish it.
right. So that's
Okay.
what I, right.
If you make it too hard, if they give you 11 hours or 36 hours, then you have a lot of opportunity to consult with other people.
No, it's too stressful to consult with other people. Unfortunately, it doesn't work that way.
Well, I don't know, with so many students, sometimes it's hard to prevent this from happening.
Yeah, one of my exams last week was 36 hours, and after that, I slept like for 2 days. I was so tired.
I don't have time to make 36-hour exam.
So I'm just saying, people don't necessarily do unsavory things because they have a long time. The exam itself inherently is very stressful, so you don't get time.
No, the final exam will be 3 hours.
And how many questions will we have in that?
Well, you can triple it.
15?
Yeah, maybe 15, yeah.
Oh,
Or
wow.
maybe a little bit less.
Like, I think 10 questions in 3 hours is just reasonable.
Maybe 10 or 12, yeah.
It depends on the level of difficulty.
No, they won't be very difficult. I told you before.
In the last question, that that integral in the last question, in the last test, the second question has that integral where we needed a table or something. That was really
But you have a
hard.
table, you have a table to consult with. It's
But
everywhere.
at the time, I thought you wanted us to show work. I never thought I could use the table. So it ate a lot of my time.
Okay, yeah. But now you know, okay,
Okay,
okay. But now you know, for complicated integrals, you don't have to do it.
okay.
Maybe I would make it more explicit. You don't have to evaluate the integral. Look it up or something like that.
Thank you.
Okay?
Thank you.
Yeah.
Have a good weekend, Professor.
You too. Well, I still have to make up your exam. So the weekend is not coming yet.
Okay. Will we have a quiz for this weekend?
Oh, well, there won't be any assignment this week.
Okay, great.
Okay?
Thank you.
Usually during the test week, I don't give any assignments.
All right, thank you.
Okay?
Yes.
Okay. You have done all the assignments for the test up to cylindrical coordinates. Good enough? Okay.
Professor,
Yes.
we have assignment 7, due
Yeah.
date November 19th.
Yeah. Yeah. You hand in on November 19th.
Yeah, so we should finish this assignment, right? Before due.
Well, I think you had better finish it because the test would cover everything
Right.
to assignment 7.
Yeah, this is a 6 and 7. So yeah.
Yeah.
Okay.
Yeah. Okay.
Thank you so much.
Okay. You're welcome. All right. So I will close this. Anything to ask me?